Hello, and welcome back to another SETI Facebook Live. Really excited for you guys to be joining us today. I'm Sarah Jennings. I'm the executive producer for FDL in the US. And Frontier Development Lab is an applied artificial intelligence research accelerator. We bring together the best in class of researchers, both from machine learning as well as domain specialists, and we pair them together to tackle challenges in the areas of heliophysics, astronaut health, lunar exploration, and earth science. This is our fifth year at FDL that's hosted by the SETI Institute and in partnership with NASA, and we're here virtually this year. We have 8 teams that are going through our 8-week program, and we are currently in week 5, where teams are focused on improvements. So today I have with me the Moon for Good team, and I loved everybody's backgrounds. It's nicely themed. So we're going to go ahead and kick things off with some introductions. So if you can just go ahead and tell me who you are and where you're from and the work that you're currently doing. And so we'll go ahead and kick it off with Valentin.
Hi everybody, my name is Valentin Bickel. I'm a PhD student at ETH Zurich in Switzerland and the Max Planck Institute for Solar System Research in Germany. And I'm interested in lunar research and computer vision, particularly object detection applications.
Great, thank you, Valentin. And Ben?
Hi everyone, my name is Ben Mosley. I'm currently a PhD student at the University of Oxford, and I'm looking at machine learning and how to apply it to physics. So combining both of those fields together.
Great, thank you. And Lavnish?
Hi everyone, I'm Nish Rana. I'm currently working in the University of Luxembourg, where I'm heading the concurrent design facility for the space systems design. I'm a PhD in aerospace engineering and a rocket scientist.
Great.
Yeah.
All right.
And I'm the last person.
Yeah, Ignacio, go for it.
Hello, everyone. So I'm Ignacio Lopez-Francos. I am originally from Spain, but now I'm based in California, where I'm currently working as an AI researcher at NASA Ames, where I usually work on cutting-edge applications for space science and research. And my interest lies at the intersection of artificial intelligence and autonomous systems. And I like how to apply these methods to interesting problems with social impact.
Great, and thank you all for joining us. I know that you guys are busy this week getting ready for your formal reviews, but we're excited to have you. And to kick us off, I'd really like to understand a little bit more about what the challenge is and why it matters. So Valentin, I'll have you kick it off.
Thanks, Sarah. So we're going back to the moon, and this time we're going back to stay. And among other resources on the moon, water and water ice will be crucial for sustaining a human presence on the surface of the moon. For example, water and water ice can be used for human life support and can be used as a source for fuel for spacecraft, for example. We have evidence that the water ice at the lunar poles in and around the so-called shadowed regions. Shadowed regions are depressions in the surface of the moon at the poles that never see the sun. And as a consequence, they are extremely cold. In fact, these regions are actually among the coldest places in our solar system. The challenge is that we don't know exactly where water ice is located. We have no direct observation of water ice or other related geomorphic features in these shadowed regions. We don't know in what physical form the water is. We don't know how much there is of it. And we also don't know where good science targets are or how to get there safely with a rover or astronaut, for example. So the images we have at the moment are simply not good enough for all of that. All images we have are either low resolution or high resolution, but with significant noise, which makes them unusable for our purposes. So our breakthrough will be to improve the existing images using AI and machine learning methods. So we want to create high resolution and low noise images of shadowed regions. And these images will be a game changer, or could be a game changer for future lunar and science exploration missions to the moon. as they will allow us to better understand the presence and distribution of water in the moon.
Great, thank you. And thank you for providing a wonderful explanation of the challenge. And we've been doing lunar work since 2017. So this is really exciting to see how the work has progressed. So I want to turn it over to Levnish to talk a little bit about what type of data are you guys using?
So we're using LRO, Lunar Reconnaissance Orbiter. So it's a satellite that's been orbiting Moon for since 2010, and it's been taking high definition photographs of the Moon at an altitude of 50 kilometers. So we are using imagery from that satellite, and over the past 10 years, the satellite has collected a huge amount of data. It's right now about half a petabyte, or that's about 500,000 gigabytes worth of data that we are working on. Each image is in proximity of, somewhere around 501 GB, and we have a total collection of near about 2 million images from the lunar surface. And each image is composed of 49 parameters in usual. So we have a huge bandwidth of data, a big matrix that we are working on right now. And so we are working on selecting target sites. We are working on selecting the particular images to train the models. Each of the image has certain amount of noise in them as well. So right now, from the machine learning point of view, we are working on denoising the images in general, which I think Ignacio will elaborate further.
Great, thank you, Avnish. So yeah, with that question, I know that you guys are in week 5. So what are you doing with all of this data, and what are the tools you're using to work on this?
Yeah, so I think a good way to maybe provide an example would be if you can imagine here, you have a digital camera or a phone, right? Usually when you take a photo during the day, it produces good results. You have a clear image. However, when you use the same settings, let's say with highlight sensitivity or sort exposure time, in a dark environment or an indoor, you usually get an all black image with very little signal. It usually is unusable. So what are the things that you can do to obtain more usable low light images in these kind of conditions? One way to do it is, for example, you can increase the exposure. However, when you increase the exposure, that means that you're also messing up with the white balance and also amplifying the noise. The good thing of using artificial intelligence, and that's the reason why we're using it for our use case, is that what we're trying to do is take this unusable dark image of the regions of the moon and then produce a light up version without the noise that you would normally get if you try to do it manually. And to do so, as Lovnis was mentioning, what we're using is the convolutional neural networks, which are trying to learn that kind of translation. And in order to do so, we need a lot of training data. So in the ideal settings, you have 2 pairs of images for the same location. One taken in low light environment, so the photo will be mostly black, and the other one taken in a well-lit condition, so you have a good signal and actually know what's going on in there. And the idea is that you can collect a lot of those pairs of images, show them to the artificial intelligence model, and then over a long time of time and a lot of computation, you can create, well, the model can create a map between this low light image and the high light image. So once the model learns this mapping, what you can do is like feed them with those images from the south pole of the moon that are completely dark, and hopefully breed them up without having the noise. The challenge for us, though, is that we cannot go to the moon and take these 2 different pairs of images. And for the images that we want to light it up, those images are in complete darkness. So we don't really know what's going on in those craters. So our approach is to study how the noise is being formed in these cameras that are attached to the lunar satellite orbiting the moon, and really understand the inherent process of electronic imaging by considering how the light goes through the several stages. So essentially deconstruct the noise. And by modeling the noise and realistically simulate that, we can overlay that noise into well-lit crater of images, and then feed those two pairs of the well-lit images and the noisy images to the network, so they can learn how to, let's say, denoise those images, and then use that for our regions in the South Pole, for example. So that's the approach that we're taking.
Great. Thank you, Ignacio. And I just also want to welcome our viewers. We have people tuning in from Tennessee, Peru, Bangladesh, San Francisco, Portugal, Denmark, Barcelona. So thank you all for joining us. And I did want to mention at this time, we have a couple more questions, but if you have questions for us, please share them with us and we'll open it up for our audience Q&A in just a moment. So the next couple of questions are for Ben. Right now, you guys are in week 5. You have a few more weeks left. What are some of the roadblocks that you guys are dealing with and working to overcome right now?
Yeah, thanks. So as Ignacio was saying, we're really trying to use AI to understand the types of noise that this camera has and try and remove it from these images. I would say one of the challenges is it's just so complicated, this noise. This camera has been orbiting around the moon for 10 years and it degrades over time. The noise in the images depends on the temperature of the camera. It depends on a lot of different factors. So trying to incorporate all those things into our AI is actually quite difficult. So we're building increasingly more complicated AI algorithms to try and to combat that problem. I think another problem or challenge, I guess, is, even if we take out the noise in these images, our real goal is to find water on the moon. And even if you take out the noise, it's not super clear how to associate water with just an image of the surface, because these are all black and white images. So imagine having like an image of the Arctic, but it's in black and white. It's actually maybe a bit tricky to say where the water ice is compared to water or the rest of the surroundings. You kind of have to look at the surface features inside the image to really interpret if there's water there or not. And then I think the final thing is about the FDL. I mean, it's a really intensive 8-week program, and time is our enemy, I guess. And we have 3 weeks left now, and it feels like it's just flown by. So we're having to be really narrow in the techniques that we choose. So yeah, that's the challenges.
Thanks, Ben. And that kind of brings me to the next question. So you guys do have the next 3 weeks to keep working, and then hopefully this work gets continued beyond that. So what is your desired outcome within FDL, and then potentially like beyond? What could you see? Yeah, so our big vision is to help humans survive on the moon by helping to find where the water ice might be on the moon. So if we're successful and we produce potential maps of where this probabilities of where the water might be, that might influence the Artemis mission, which is NASA's mission to put humans back on the moon in the next decade. So we might be able to inform them where best to land on the surface, where there's water nearby, to help humans to sustain human presence, but also to provide things like rocket fuel. And there's also a lot of rovers that are going to be landing on the moon, and being able to light up the images of these shadowed regions might help us plan where those rovers can do and can be into the activities that they partake in. So, yeah. Great, thank you, Ben. And while we're waiting for some of the questions to come in, you guys are in a particularly interesting position because you guys have the ability to build off of previous FDL work. So I wanted to ask you guys, we've had an amazing partner in the Luxembourg Space Agency, and how have you guys been able to take the work that was done last year and to be able to use that and to build off of it?
I guess I'm the only one here from Luxembourg, and ironically, I'm the newest person in the Luxembourg agency. So in that sense, yeah, the whole idea about Luxembourg being interested in the space resources is to be of the economy, to be of from the point of view of the economical point. And because right now when we are going to the moon, it's not from the Cold War, or the way we went in this. It's right now it's from a commercial point of view, and that's where Luxembourg is trying to place itself. So going to the moon, NASA has the Artemis mission, but beyond that, there's a lot. Europe being a major player in that. So in that sense, Luxembourg is very interested in mining the resources on the moon, and water being the most important one of them. Luxembourg is very interested in finding towards mapping the water, towards investing into the technologies and the companies that are going to go to the moon and stay there for good. So in that sense, the point of view from Luxembourg is very financial and very pragmatic. That it's to boost the economy of the country of Europe and eventually have a sustainable presence on the moon.
Great, thank you. And Valentine, Ben, and Ignacio, since you guys were a part of last year's work, how have you seen that progress?
Yeah, I think it's having worked on the FDL last year, it's really helped us work in this new virtual environment. So that the whole of FDL is virtual this year. And to have already met a lot of the people in the program means we can kind of hit the ground running with kind of our relationships with each other. And yeah, that's definitely a help. I think also we're reusing a lot of the kind of algorithms or code or whatever that we used last year as well. So because we looked at the moon, we looked at kind of similar data sets, and so we already had kind of the infrastructure to handle all the data in place. So that was another factor, I think.
Great, thank you, Ben. That was really wonderful, both Levnish and Ben giving that perspective of both Luxembourg's interest as well as how the work has progressed. So we got a wonderful question from somebody in the audience about, do any of you want to go to the moon? So Valentine, do you want to go to the moon?
That's a yes. That's it.
All right, Ignacio?
Yeah, of course, I think so. It's definitely a shorter trip than going to Mars. And you can come back, which is a nice thing.
Yes, awesome. And Ben?
Yeah, absolutely. Of course.
And Levnish?
Yeah, of course. Like, I think that's been a childhood dream forever. So why not? I think all of us. I mean, we are working on finding water on the moon. So yeah, that's an obvious yes.
Great, wonderful. And I mean, obviously part of your work is looking at how can we do like sustainability on the moon? How can we go back to the moon for good? So I want to remind all the audience, like we are taking questions, so feel free to submit those to us. I would like to know what mission you guys are most excited about, and why are you excited about it? Does anyone want to take that one first? Ignacio, do you want to go first?
I can go. Well, I would say the mission that I'm most excited about is in 2023, we're planning to send a rover to the moon. That name is, the rover's name Viper, because the main goal of this rover would be to try and explore and dig and find ice water in the South Pole of the moon. And this is very, very exciting because it will be the first time that we actually go into the South Pole and we explore that area, and we actually can finally find evidence and confirm the studies that we've made, that there is in fact water on the moon, which will enable sustainable settlement of humans in the moon in the future as well. So for me, that's very exciting also because where I work at NASA Ames, there's a team focusing on that challenge, and most of the software is being built in-house. So yeah, I would say that's my favorite for now.
Great, thank you. And Levnish, I'll go to you next. What are you most excited about?
For sure, South Pole, because that's where we have the highest possibility of finding water. But at the same time, yeah, Moon overall is good enough, right? I mean, it's Moon after all. So in that sense, and I think it's going to be the next stepping stone. If we talk about a long-term vision, Moon is like the pit stop or the gas station. So in that sense, for humans to become to become a species that goes beyond Earth, Moon is the place that we need to have a sustainable presence on all the time. And then from there we can go to Mars and eventually anywhere else. So yeah, Moon is significantly important for everyone, and NASA is taking the first big step. And I think eventually, I hope there's presence from all the nations of the world. So yeah, it's exciting times right now.
Yes. Wonderful. All right, and we'll go over to Valentin.
So I'm very excited about the upcoming CubeSat and SmallSat missions, like Flashlight or Trailblazer. Those missions are going to provide a lot of new high-resolution data that we can use for all kinds of analysis, like thermal mapping, mapping in general, mission planning, and so on. So those are going to be very exciting. I'm looking forward to the data.
Great. And Ben?
Yeah, I'm most excited about the Artemis missions. So it's a sequence of missions, but the penultimate one, or the biggest one for me, is the landing humans back on the moon. And I think some of us, I certainly am part of like a younger generation that didn't see the moon landings in the first time that they happened. So I think once we see that and the world sees it, I think that will really provoke a huge public interest in going to the moon. I think that'd be really exciting to see.
Yeah, I think that's definitely true of everybody that's on this call today. So I'm also very much looking forward to that. So we got a question from the audience. Can the work that you're doing be applied to other planets? And I'll extend that to like other, celestial bodies.
Yeah, I can take that if that's okay, Sarah. So there are shared regions on other planets as well. For example, planet Mercury. So we can apply our methodology in these kinds of regions as well. So we could take imagery from Mercury, for example, the Messenger probe, or the upcoming Bepi-Colombo mission from ESA, and we could apply our methods there to see if we can improve the signal in these shared regions to help science and exploration efforts. Yeah. It's a good question, though.
Great. All right. And then I think we'll have time for one more question. So this one I'll ask more about your FDL experience. Since you guys started, we'll just keep it with this project of FDL for this year. What is one new and interesting thing that you learned? And I'll go ahead and start with Ben.
What a new and interesting thing I've learned. It's hard to pin it down to one. I think one of the great things about FDL is we have weekly stand-ups with the whole community, and every time one person presents a thought of the day or something really interesting that they don't think that the rest of the group has heard before. So there's been a whole load of those. Been really interesting. The one that I enjoyed was someone was telling us to get up and stretch, and they were giving us good yoga positions to help us stretch because we were sitting in our chairs all day. So yeah, that was a good one.
Great. Yeah, I think that was Ocean. So yeah, we got to do a little bit of yoga there. So great. Ignacio.
Yeah, I was going to say this year, because of the settings of having to do it virtually and not being able to be all here in California, I think it's been itself an experiment. But we are now in week 5, and one of the biggest discoveries for me is that we can actually get a lot of work done by just working remotely in the settings. I know it's not ideal, but I think that we're very fortunate today to have the kind of tools to have, the internet, be able to collaborate, from people from all over the world, be able to communicate I think that that's been a great discovery, because that means that you mean so many of the things that even before we have this physical barrier of collaboration, we could only collaborate maybe with people closer to us. Now, you know, we are still have to deal with the time difference, which is actually very challenging. But I think that we've been able to really collaborate very effectively, despite obviously the conditions of this virtual setting. So that's it for me.
Great, thanks, Ignacio. And Lavnish?
Well, FDL, I think the newest addition to the team. This is my first year in FDL, and in contrast to what Ignacio was saying, I was really excited to go to California and work in Ames, and also because until last year I was in Texas for past 8 years, so it had been like about a year, and I was looking for an excuse to go back to States and see my old friends, some of them who are in California. But regardless of that, FDL has been overall a very good experience for me, because I'm traditionally not from the machine learning or artificial intelligence background. I'm from a very pure aerospace, rocket science background. So just being with specialists from AI, all my team members here, it's been a great learning experience for me personally. And yeah, just being exposed to and finding a whole lot of applications that I'll be applying in the coming years. I'm right now working in the remote sensing group here in Luxembourg. So we are already looking at, like, the techniques that we are using here, that we can eventually apply in a lot of the even the Earth observation cases, and bring more value to the data that we usually have for free available from a lot of Copernicus or a lot of satellite imagery that we have available for Earth. So in that sense, it's been a great experience for me overall.
Awesome, thank you. And Valentin?
So I'm with Ignacio on this one. I think it's fantastic that we are able to work on such a high intensity challenge with a team that's scattered across the entire globe. Thanks to FDL and all the research that we receive from FDL and its partners. So this is a really unique experience, and I'm looking forward to produce something that can be of use for the entire scientific community and the public as well, hopefully.
Great, thank you. Yeah, and I'm also
It's
looking
great
forward
that,
to, oh, go ahead.
that I rather have this obviously in present physical. I think that would have been an amazing experience. But yeah, given the circumstances, I guess we'll always have the moon to meet there one day together. Because yeah, I mean, it's sometimes it's hard, right? I mean, Ben, Valentin, and I, we are very lucky, and obviously we know you, Sarah, too, from last year. But you know, it's so many of the other groups. It's the first time that they meet, the first time that they have to collaborate in these settings without really knowing each other. So I can completely understand how loneliness feels right now. So it's always hard, and that's why communication is so important. And yeah, I mean, the amazing organization from FDL and Trillium Technologies that have put together this program, which is really hard. It was the first time that they do it virtually, but it has really created this good atmosphere for collaboration and communication between us researchers and also the faculty as well.
Great, thank you, Ignacio. Yeah, I'm really excited that we're able to continue all of this really amazing work even in a virtual environment. And Lavnish, I look forward to going back to Luxembourg and hanging out there, and also going back to NASA Ames with everyone. And hopefully, eventually, we can all meet together on the moon. So with that, I would like to thank all of our viewers. This has been wonderful. Thank you to all of our researchers that were able to spend time with us today. And I look forward to another SETI Facebook Live with you all. Thank you.
Thank you, everyone.
Thank you, Sarah.